This is an analysis of RL circuits. An R is a resistor, an L is an inductor. We've got the circuit here with a battery, with your resistor, your inductor, and a switch whereby we can connect or not connect to the battery. So let's take a look first of all at a simulation of what's going on in the circuit. So if we build a simple circuit, I'm going to pull a wire, a resistor, a battery, and put a switch in here. Now if I pull a current monitor down and we look at what happens to the current when we close the switch, notice the current increases dramatically and very abruptly. That can be very harmful for elements in a circuit. So let's disconnect, and now I'm going to add an inductor in here. An inductor is basically a coil of wires, in this case pictured like a solenoid. And now let's consider what happens to that current. Your inductor fights the change, so you get a gradual curve on the increase of current instead of that abrupt change. Now let's relate that over to the actual circuit and the math of the circuit. Now back to the actual circuit. So if we analyze this, we're going to analyze this with the loop rule. So looking at the change in voltage across each of the elements, the EMF, the resistor, and then the inductor, we know the total change around the circuit is going to be equal to 0. Now what we have to figure out is the signs of each of these. The battery is supplying, so we're going to take that as a positive. The resistor is dissipating, so that would be a negative. And the inductor is storing, that would also be a negative. So there is our loop rule. Our goal here then is to be able to solve for an I of t equation. So then in our line here, what we want to solve for is I. Now we've got an I there, we've got a di here. First thing we're going to have to do is do the algebra to be able to get the I and the di on one side and anything else onto the other side. So if I solve this down, I'm going to take and get the di dt alone. So I'm going to move the other two terms over. So that would be a negative EMF plus IR is equal to negative L di dt. I'm going to divide the negative L over, so that's going to give me EMF minus IR all over L is equal to di dt. Now I can get all the I terms, so I'm going to partially cross multiply there. So I'm going to throw the dt up. So I've got 1 over L dt is equal to di over EMF minus IR. Now I've got the I terms on one side and everything else that I can do to get everything on the other side. Now, if I'm going to solve, I'm going to integrate both sides. Over on the left side, from 0 to t. Over on the right side, this would be from the initial current, we saw that on the graph to be 0, up to whatever the current I value is. On the left side, if I integrate, I'm going to get T over L. On the right side, we're going to have to do U substitution. So if I look at doing U sub, I'm going to let U be equal to E minus IR. Okay, then du di would be a negative R. And so then di would be du over negative R. So if I bring that back and I substitute in here, I'm going to get the integral of di gets replaced by a du over negative R. EMF minus IR gets replaced by a U. If I clean things up, this is going to be a 1 over U. Now, if I clean things up, I'm going to take the negative R, I'm going to take it to the other side because it's a constant. So this is a negative RT over L is equal to the integral of 1 over U du. If I integrate that, that's going to be negative RT. Let's not go so low on the screen here. I'm going to remove my U sub stuff so that I am able to write. So now I've got negative RT over L is equal to integral of U to the negative first power is going to be natural log of U. Okay, now putting back in our U sub stuff, this would be the natural log of EMF minus IR evaluated from 0 to I. So now if we plug in negative RT over L, this is going to be natural log of E minus IR minus the natural log, when we plug in 0 for I, we're just going to get natural log of EMF. The difference of two natural logs is going to be the ratio. So this is natural log of E minus IR over E. Now to get rid of the natural log, I'm going to go up to raise it to the E. So I'm going to come back over here. And so we're going to get E to the negative RT over L is equal to EMF minus IR all over E. Now basically what you have left to do is just solve down for I. So I'm going to multiply the EMF over, so I'll get EMF base E to the negative RT over L equals EMF minus IR. I'm going to subtract the EMF to the other side, so I'll get negative EMF base E to the negative RT over L is equal to negative I times R. And so then dividing everything by R, I've got negative EMF base E to the negative RT over L. So I subtract the EMF over there, so I've got a negative EMF, E plus E